analysis. Choose your file, and here is mine. This will be 30 frames per second. We actually do want to use the time function on here. It's not slow motion. Weird things don't really happen. This notices it's 30 frames per second, which is as it should be. Not going to bother with the scale, so I'm on step 2, by the way. But I do want to set the origin. And I need to go to the point where the rocket is about to launch before I set the origin. There. Because what we're measuring is the heights on the screen. The height of apogee and the height of parachute deployment. The units are not going to be important. It's the relative heights on the screen that are important. Okay, so I've got that. Now I'm going into add, and I need to record the time, and the time for takeoff, apogee, parachute deployment, and then landing. And I need to get the heights for apogee and parachute deployment. All right, there, it's about to take off. I'm just going to go ahead and click here. Now, this gives me the Y position. It doesn't really matter. It's in pixels. That's meaningless for now, but the time is 0. That's the important thing. I'm going to zoom out and just play it at the ordinary speed and see where it gets to the highest point. Right there. Now let me use these to go back a little bit. I can see it's going down and going up. Okay, somewhere right about there. That's the highest point. Now I want to mark where it gets to where the parachute fully deploys. And I think this is more easily done in real time than it is frame by frame. Okay, right about there. Maybe I'll go back a few frames and click. So you can't tell it here. I'll let you see it in just a second, but I didn't keep the camera entirely still. I should have kept it still from the moment of launch until this fully deployed. But I didn't. I moved it around a little bit. I will do that when we do this in class. But let me go back. See how the ground is moving? It's pretty good. I don't know. It's just pretty bad. So I need to figure out some way to keep it steadier, because that's going to affect how we measure those heights. Okay. So I need to collect one more point, and that's the very end where it hits the ground. Zooming in. The nose cone's hanging here. So when that touches, that's my time. All right. So I've got times here. 0, 2.93 is apogee, 6.2 is deployment, 36.94 is when it touches the ground. And on my data sheet, I need those 3 times, so I can just copy them right from here and then paste them right there. And now I need Y position at apogee and Y position at parachute. This gets a little strange. So this is Y position at apogee, 1446 pixels on the screen, and parachute deployment, 1213.8. I'm just doing it in pixels. It doesn't really matter what the units are. It's the relative height that's important. So I'm putting those in here. And later on you can do this calculation, but I'm going to do it now. This is the fractional height expressed as a fraction of apogee equals parachute deployment height divided by the apogee height. And that's about 0.84. So what that's going to allow us to do is at the point, whenever we get to, or whenever you get to figuring out using another spreadsheet what the actual height at apogee was, you can multiply that by 0.84 and that'll give you or whatever your number is, that'll give you the height at parachute deployment, which we won't be able to get easily in other